Hello guys, today we are going to talk about the term called vacuum filtration, and this vacuum filtration will be using in to separate the dye from the water. So the word vacuum filtration is basically also called suction filtration, and this is the mechanism of separating or segregating a solid from a liquid through a filter element. Here the vacuum creates a driving force that pulls the liquid through the filter while the solids cakes on the outside of the filter. Now what does the filter do? So the vacuum filter basically uh, traps the dirt and other particles from being expelled into the into the other sources. The difference between the vacuum and gravity filtration is that timeliness and how they operate. Basically these are the two ways we can differentiate. One method uses a vacuum source in case of vacuum filtration to power the filtration, while the other uses the gravity. Okay, there are other mechanism also to remove the to do the filtration. This is dead end filtration, okay, and the cross flow filtration also. In the vacuum filtration device, we just use the membrane filter, okay, a microporous membrane, okay, a filter cup which can hold the sample in the range from 100 ml to 500 ml, okay, a triangular liquid collection bottle where you will get the filtered sample, a sand core filter also sometimes, and a fixed aluminum clamp from where you can clamp the the holder, sample holder to the to the vacuum filtration system. And this system is basically used in laboratory vacuum filtration, so it can intercept the particulate matter, clarify filtrate, sterilize, solid liquid separation, degassing, defoaming, and other purposes. So shortly we will see how to perform the triodes in the lab. So hello friends, today we are performing the vacuum filtration, okay, and this vacuum filtration basically we are going to do for the separation of the dye using two membranes. So first membrane is my PVDF based membrane, which is PVDF is being as a support membrane for this is our CNT based PVDF membrane, and this one is the commercial membrane which is called cellulose acetate membrane filter. So we will check the efficiency of both the membranes for the separation of the pollutant, which is methylene blue. Okay, task is to find out the concentration of the pollutant, which is methylene blue. So the concentration here is around 6.184. so this is our initial concentration. Kept our membrane here, okay, then we need to clamp this. After clamping, what I am doing is putting the solution here. This is around 10 ml. You can also calculate the time and flux also. So we will run it for around 5 to 10 minutes. And now after clamping this filter and the whole setup, since this is vacuum filtration, so it is going to work for around 1 bar, so which is slower than the membrane filtration and dead end system or the closed flow filtration system. Now slowly and slowly it will purge or remove the water. So the time calculated is less than 1 minute. Now let us find out the final concentration. I have transferred the remaining residual dye after the separation of the mixture. Now we can see also it has taken away a chunk of the dye on its surface. So usually if the flux is higher, it means if the membrane is very good in separating the pollutant from the liquid phase, and also depends on the pore size or the opening size of the membrane. Okay, so now this is my separated diluent, or you can say the dye. So now I am measuring the concentration of the dye. So in the beginning it was around 6.184. Now it is drastically reduced to 2.675, so which is a very high percentage. You can also calculate in terms of percentage, I mean separation. Okay, so this was all about the cellulose acetate membrane. Let us now check the other membrane, and also we can regenerate the membrane. So this membrane can be regenerated in soaking in some specific kind of eluent or solvent like HCl or nitric acid, not the concentrated one, but I mean lower dilutions like 1 molar, 1 normal, okay, or some kind of, I mean, other elements like alcohol, I mean ethanol or acetone also. Okay, so this all depends upon our objective. So this is for the regeneration basically. Now let us check this membrane. So we need to clean and remove this membrane. This membrane now here at the top, I need to add this. Okay, and then we need to clamp. So let us add around 10 ml here. Start to operate. You can see the water is coming out, and we can, unlike the other membrane, we can calculate the time and the flux also here. So this took around 2 minutes for all the water to come out. So now let us check the concentration of the separated water. So this is around 1.625. So this is much better than our previous membrane, cellulose acetate membrane. Okay, and we can also calculate the percentage separation. Okay, now to use the membrane again, which you can see the first membrane is after separation, it looks like this, and this is our first membrane. So we need to soak them in specific solvent. Okay, so this is all about the separation of the dye loaded water using the vacuum filtration technique.